Okay, hello everyone and welcome to our monthly webinar series. My name is Jamie Spicer. I'm an assistant professor at Wake Forest School of Medicine, and I'm organizing this webinar series that is sponsored by the section on statistical learning and data science of the American Statistical Association. Today, we are honored to have my colleague, Dr. Byron Jaeger, talk about Git and GitHub. Dr. Jaeger is an assistant professor in the Department of Biostatistics and Data Science at Wake Forest School of Medicine. He recently joined our department and we're very happy to have him. His research interests include prediction models, machine learning, and statistical programming, as well as collaborating with researchers in hypertension, cardiovascular disease, and heart failure. So the format of Dr. Jaeger's talk will be a little bit different than some of our other talks. He will give an introduction for about the first half of our time today, and then we will pause and we can answer questions at that point that have arisen. And then we're going to do a little tutorial, which is interactive. And Dr. Jaeger will lead us through that. And then after the tutorial, there should be some more time for questions and discussion. So I'd like to thank Dr. Jaeger and the sponsor of this webinar, the Statistical Learning and Data Science section of the American Statistical Association. And Byron, I'll go ahead and turn it over to you now.
Great. Thank you very much, Jamie, for the lovely introduction. And also thank you for inviting me to present here for the section on statistical learning and data science. I am going to be presenting these slides in a second, but before I roll into those, I would like to encourage everybody to open up chat, where you'll see there should be a link to the slides in the chat. And I'd love it if you would follow along, because we're going to get to slide 10. And once we're there, you will see there's a little question for you to answer. Let me just post the link for you again. Let me do that.
Here, I got it. I just posted them again to the chat.
Perfect. And for future reference, if you ever want to follow up on these slides, you know, this is a talk about GitHub. So the slides are on GitHub. And by the end of the talk, it should be fairly straightforward for you to navigate back to them with your own GitHub profile. So you should hopefully follow along to at least slide 10, where you'll be engaging with some questions that will help me understand the audience a little better. And then you shouldn't really have to follow along that closely afterward. So why don't we go into the slides now? The title of this talk is Happier Version Control with Git and GitHub, and if we have time, Rstudio. I'm very excited to give this talk. I'm going to start by saying hello. My name is Byron. I have kind of become known as this guy who chases his colleagues around campus and says, listen, I know you're already doing your work and all, but I bet you would love to just do that in R instead. R is a programming language that I've used for a while, and it's become a big, essential part of my work. So interestingly, though, Git has also really grown on me over the years. And I find Git to be just as essential now as I think R is. And so it's really exciting for me to be able to talk to you about Git. However, I do want to point out a few things before we go into things. The first is that I have taught myself Git over the years, and I'm giving you a lot of the materials in this talk that I use to teach myself. So these are recycled materials. The first thing is there was a great talk by Alice Bartlett called Git for Humans, and I've adapted some themes from her slides. I've also taken 5 things about Git that she listed, because she's presenting, what's good about Git, and I think she just got it right, so I don't want to change her answer. I'm also going to be using a lot of content from Jenny Bryan. She's a research scientist at Rstudio, and she's been involved with improving access to Git and GitHub for about half a decade. And I'm also going to say her textbook, Happy Git with R, that would really be the ideal resource to go to after this talk. And in case you're wondering, all of this pink text is actually hyperlinked. So if you just click on any of these pink text things, you'll be taken right over to the, the place where it seems to be indicating. So I am just recycling these materials because I learned from them. I think they're great, and I wouldn't want to change anything about them because they probably can't be improved on. So the other thing is I am a basic Git user. I know the basics of Git pretty well, and I don't think I need to know much more. I've been using the basics for a while, and the advanced stuff is maybe geared for more intense software projects, but for the purpose of data science and just collaborating with people, the basics are really good, really effective. All right, so now I'm gonna take a brief section and ask you to provide some information about yourselves. In your slides, you should be able to see an interface like this. It's gonna ask you if you'll accept cookies at the bottom. And of course, you would never not accept cookies, so go ahead and allow those. And then give me your answer to this question. I'll go ahead and put my answer in now. And what should happen is people will respond here, and then after we get a fair number of respondents, we can get a better sense of what the audience is. Oh, great. This is what I was hoping for. I was a little bit worried that everybody would already be using both Git and GitHub, so that would kind of make my talk a little bit less useful. But it looks like we have about 60% of people who don't use either Git or GitHub. Everybody seems to have heard about these before now, which is great. There are a couple of people who use Git but not GitHub. Very interesting group. So we got about 26 respondents now. It's probably stable estimates. So about half of y'all are, not users of Git or GitHub right now, which is great. And what I hope this talk will do is kind of give you a sense of excitement or curiosity about how these tools might impact your work, and you might even feel excited about trying to bring them into your workflows. And if you already use both, I'm super glad you're here. There's a good chance that if you're already using both, you may know more about these platforms than I do, so your input could be very helpful. So the next question is, how do you feel about learning how to use in GitHub? Learning how to use Git and GitHub? And I'm just going to say, yeah, great. This is kind of just something I have to write in order to get to the screen where people will, where the answers will be visible. So I see messy. I think your expectations are good. Interested, excited. Oh, this face. Afraid, I like that. Uncomfortable. Mostly interested and excited though, which is great. Sadness, that is an answer I can identify with. Learning GitHub and Git made me feel very sad, uncomfortable. Good question, thank you, I appreciate that. Confused, that one, yeah, I've been confused for a while with this. This is awesome, thank you for being honest and sharing your thoughts on this. So interested is great. Let's go ahead and go forward with the talk now. I'm going to start just by talking about Git, giving you as much background as I can to help contextualize what this thing is. And by the end of the talk, what I hope you will think and feel is that you could go to this really comprehensive textbook written by Jenny Bryan, which has detailed instructions on how to connect Rstudio with your GitHub account, and also link Git to Rstudio so that you can use Rstudio as the hub that manages all three of these, manages itself as well as Git, as well as GitHub. So the book will give you instructions on how to do that. And what I hope my talk will do is make you feel excited enough about integrating these tools to go to the book and go through the steps and get them connected. Because I think from there, it's pretty, I'm not going to say smooth sailing, but it's a lot better than just using them as disparate applications on your computer. So that's the goal. All right, what is Git? What Git really is an application that runs on your computer. It functions like Microsoft Word does and Chrome does. It has the same, it is the same type of thing. but it is also a version control system. So its original purpose was to, I'm just going to go into full screen now that I don't have to alt-tab to anything. Its original purpose was to help groups of developers work collaboratively on really big software projects. There's a question in chat. Oh, there we go. Thank you, Jamie. I appreciate that. So going on to the next slide. So what exactly does Git do? I will say this hopefully a few times throughout the presentation, but Git manages the evolution of a set of files. And in Git terminology, a set of files all sitting in the same directory is called a repository. So this feature of Git is a little bit like track changes with Microsoft Word, but it's extended from one file to that whole set of files. So Git can tell you if there's a change in a file. Git can also tell you when there's a new file, and Git can also tell you when a file was deleted. And so next question is, who made Git? The person who made Git is Linus Torvalds. Linus is the developer of Linux, which he named after himself. And in the process of developing Linux, Linus's team had, the challenge of working together on a very big software development project. And in fact, Git was developed to help them meet that goal of developing Linux, because it was a big group of developers. They were doing something very complex, and they needed to work together in a safe, robust manner. So Linus actually developed Git so that he could finish his development of Linux. I got mixed up with his names there. And it's been speculated that Linus also named Git after himself because he thought of himself as a Git. I have no idea if that's true. I've just been reading a lot about Git in the last couple of weeks, and I thought that was an interesting, maybe perhaps fact. So Git was originally developed for big software development projects, but it's been repurposed a little bit in the past couple of years. So nowadays, people in the data science community are using Git with a lot of help from GitHub to do data science related activities. So for example, and all of these are links that you can explore, people have used Git and GitHub to write books out in the open. Some examples are Hadley Wickham's R for Data Science. He's also got a book on Shiny, which is a R feature. It's, sorry if that's, Shiny is kind of a weird jargon term for R. There's also some GitHub repositories where people manage their own personal website. And this link will take you to the website of a person who's in an academic career. And they're having a very successful academic career. So their website's pretty interesting. And this last link is actually a link to one of my GitHub repositories. So I'm going to go ahead and click that real fast. So it's fun to go to this link because I'm guessing a lot of people in the audience have engaged in writing scientific articles. And there can be a lot of tedious stuff in the process of writing scientific articles. So what I've done with this particular GitHub repo is tried a new flavor of working with my colleagues, which is where we write code for every single thing in the process of creating a manuscript. Code to get the data, code to do the analysis, that's not really new. Code to create the paper, code to create the figures and tables, code to put everything into the right format for the journal. And since it's all code, it's pretty easy to manage on GitHub. And now at the end of this, we have this repo that a person can download and literally reproduce our paper. So like if you go into the doc folder, I believe. Yeah, so you can see here the actual markdown that's used to produce our paper. And if you go through this markdown document, you'll find that when we actually present our results, there's all these little R markdown place-ins. I'm just going to scroll for a second. Yeah, so you can see all these R markdown place-ins that we're putting in, because when we run the whole pipeline of the project, the objects here get updated with the most recent data that we've produced, and then that data gets placed into the manuscript. And it has been an interesting process because, collaborating with non-Git users on GitHub is always interesting. And you have to do a little bit of teaching at the same time as you're doing your collaborative work, but it's really paid off in the long run because we've made updates to the project, we've made updates to the paper, and the updating process has been a lot more seamless, giving us the opportunity to make big changes down the road that don't create huge roadblocks. And we've never once used copy and paste to get our new results brought into the current paper. So what I can do now is kind of go forward. And I'd just like to talk about Git from the perspective of a beginner. So when you first start using Git, the first thing you'll notice is that it is super unfriendly. It's a tough application to learn. I'd love to credit Allison. She was the one who initially used this photo of Linus in a talk. And this is, Linus was doing this gesture for a totally different reason. He doesn't have feelings about Git for beginners, but it might seem like he does. It might actually seem like he designed Git to frustrate you and make you feel like you didn't understand how to use software. But the reason that Git can be difficult for beginners is that it is a terminal application. So this is a view of me using Git while I was creating this project. And using terminal applications can be really difficult because in order to use the terminal, you have to know what you want to do, first of all, and then you have to know the commands to do it. So when you don't know what you want to do and you don't know the commands to do it, it's just super unapproachable. And generally, nice discoverable software will have these features that are built in to help you determine, you're working on your project, and the software can help you determine what you need to do. And then the software can also give you some documentation and pointers to tell you how exactly to do that. And so Git has neither. Of course, there are applications built on top of Git, like Git Kraken and GitHub Desktop, that can help build those features up for you. But even with those, it's still kind of hard to learn Git because Git has this huge amount of jargon. And when you look at the documentation for Git, you'll see that a lot of the things that, a lot of the jargon is actually defined using more jargon, because a lot of the terms that are specific to Git are dependent on other terms of Git. So you can't define some Git terminology without using other Git terminology, which is fine. But as a beginner, it's just annoying because you can't, it's just you're reading about something that you don't understand, and it's just jargon explained by more jargon. And so it can be very, very difficult. Oh, I see this question in chat. What is a terminal? That's a great question. It's a command prompt where you can put instructions into your computer about what application you'd like to use and how you'd like to use it. I'll probably just bulldoze through some slides here, and then I'll take a break halfway through the presentation to read more questions in chat. So I'm just going to close it for now. So now that I've brought up these limitations, you should be wondering, should I even use this? Which is a very good question. Of course, my answer is yes. And I'm going to give you 5 reasons why it's a good thing to learn, even though it can be a little distressing to learn it. Back to full. So the first thing I'd like to go through is that Git will kind of transform your project into a story, let you tell the story of your project. And I'm going to kind of go through this and highlight. Sorry. Give me 1 second. My dog is barking. I'm just going to calm it down. It's okay. Okay, I think he's fine. Yeah, I knew this would happen. But I think we can get back into this now. So as I go through this, I'm going to highlight those like jargon terms that are so important to define. So what Git does, it allows you to take snapshots of all the files that are sitting inside of a folder. And this folder is referred to as a repository. Sometimes it's, geez. Okay, 1 second. It's fine. Come on, kids. It's fine. Kids, shush. 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 Sit. Shush. Okay, this time I think we're good. So what Git does is allow you to take snapshots inside of a repo. Now, when you want to take a snapshot of your whole repository, you create what's called a commit. So this kind of mirrors, well, I've kind of seen this sort of version control system done in many workflows in the past, including my own workflows. What people tend to do is create a file. So here I've got a script called data_load. And then as they progress in their project, they will create new versions of the file, and they'll change the name of the file to indicate what they're doing. So I created data load version 2, and then I go to a meeting and I get some feedback from a colleague. So I get their feedback and I make a new version of the file and I append their initials to that file version. And then I feel like we're getting close to the end of the project, so I've got a good sense of what this file should be, and I create the final version of that file. Then something unexpected happens, and we get one more team meeting, so I then create version 2 of the final version of that file. And this is kind of the standard file naming convention that I've used in the past for version control. And when you're making commits, inside of Git, you have a different system that is gonna be used. So when you make commits, you will develop this linear history of your repository. And as you make these commits, you're not going to be changing the name of the file, but you will be committing a different version of that file. And so as you go forward in time, your file will remain the same. You don't have to have multiple copies of it in your directory. But every time you make a commit, you will be saving a different version of the file. And when you do this, you develop a nice little linear history of the file. So when you make this commit, Git is going to save a little bit of information for you automatically. It's going to tell you who made the commit and also when the commit was made. In addition, you can and should add a little bit more information about the changes that you're making with a commit message. So a commit message is going to be composed of 2 different things. The first thing is the header. And here you should say in very concise terms what the commit is titled. So generally, I try and finish the sentence, this commit will blank. And that's what my header is going to do. So I'm going to prevent factor coercion with this commit. And then the important thing here is the commit message. Best practice for commit messages is to explain why you are making the changes in your commit. And it may be tempting to say what changes you're making, but you really don't need to, because Git has this track changes feature, which will explain exactly what changes you're making. And so there's no need to repeat what Git is already doing for you. But when you look back on your work and say 1 year or 2 years or 5 years, or like however long it takes JASA to review your manuscript, you'll be wondering, why did I make that change? Because it always kind of leaves your mind. And so having a little reminder of what you were thinking at the time is very, very helpful. So in this example, we have a little explanation. It says that character vectors may be automatically converted to factors by some data import functions in R. And our data management is going to directly change some character values. And so if there are factors when we try and do that, there's a chance that it's going to create missing values. So this commit, we're going to set up a delaying mechanic so that things don't get converted to factors until the modeling phase. And in case you're wondering, I will explain this a little bit. I'm going to just divert to talk about R for a second. In R, if you have a character vector like this, you can then create a factor by just using the factor function and then supplying this character vector as the data. And the factor vector is going to recognize, whatever character values are supplied to it when it's created. So if I try and run this code where I modify the second value of this factor to turn it into a D, the factor isn't going to recognize this character value, and it's going to replace it, instead of replacing the second value with a D, it's going to replace it with missing, which is expected behavior for a factor, but they don't necessarily teach students about this in their first statistics course. And so the mistake can be made by many, many people. So it makes sense sometimes to delay conversion to factors because you want to directly manipulate your character values. And so not that this, making commits is good, even if your commit messages aren't perfect. But if you were to think, okay, what would be a bad commit message? I would say this is not a helpful commit message because it's just saying, here's the change that I made. And if you opened up the Git commit within GitHub or just looking through your Git diff files, you would be able to find this information pretty easily. So this commit message isn't as helpful as the original commit message. But commit messages, along with the information that Git stores for you automatically, tend to have a whole lot more expressive power than just this. So it's far more easy to navigate your project and look through all of its history when you've set it up as this linear history with a kind of story attached to it. So once you have this linear history set up, you can travel through your commits and you can see why you made these changes, and you can see when they were made, who made them, what they were thinking. And you don't have to worry so much about like, what am I going to name this file next? And you never have to be embarrassed about naming it final and then appending it with like final version 2. So we've covered a little bit of jargon. I'm going to try and review it as we go through. The first term is a repository, and this is a folder that contains files. It can be any kind of file. It doesn't have to be a special kind of file. So it can be images, data, code, any sort of file. Just has to be sitting inside of a directory. Next up was the commit. This is when you take a snapshot of all your files. It's the mechanism in Git that allows you to create this linear history. So the next thing about Git that's nice is that it allows you to travel through time. And because you have this sort of linear history, you can go back and see what your project looked like at a specific point in time when you've made a commit. So here's a little visualization of our project over time from left to right. You can see these last 3 dots are the 3 commits that were in the previous slide. And Git represents these commits internally with something called a hash. So the hash, shown here, is this very unfriendly string of characters that represents a commit to Git internally. When you want to go back in time and look at your project at a certain commit, you do what's called a checkout. So a checkout is going to move back to a specific commit in time, and you can tell Git which commit you want to look at by using that hash ID. And so let's say that I realized I wanted to change something just after I renamed these blood pressure variables. What I'm going to do then is go back in time, or I can't really change anything about this. You can travel through time with Git, but you can't change the past. So maybe I just wanted to look at something in this commit that I did right after I renamed my blood pressure variables. So I can tell Git that I want to go here and use the hash to indicate which commit I need to go to. And what happens when I do this is that I'm going to check out the version of my project at the exact moment in time when this change was made. So what it looks like is your entire project files may be removed, files will be changed, everything will be reorganized to look exactly as it did when you made this commit. And you may be alarmed because it will seem as if you just lost all the work you did. But it's not that the files have disappeared. It's just that you're looking at a snapshot. So everything is still there. And to get it back, you just need to go check out the most recent commit of your project. And that way you won't lose work, but you can easily just transform your repo to look like it did at a certain point in time. So the hash is a computer-generated ID for a specific commit. The checkout is a command in Git that allows you to time travel to a specific commit. So the third nice thing about Git is that you are able to experiment with Git. And so far, what we've kind of described looks like this linear progression in your work, very neat and orderly. But in most projects, you end up with a lot of nonlinear avenues of work. A lot of times you need to design and follow through experiments. And most of those experiments, some proportion of those experiments won't work. You need to be able to sort of create these easily discardable experiments to work effectively. So in Git, you can create these easily discardable experiments with something called a branch. The technical definition of a branch is a movable label, which you can attach to a single commit. It's a little bit confusing because the terminology branch kind of creates this image in your head where you see a branch coming off of a tree. And so you may think like, oh, a branch might be like a sequence of commits that comes off of the main branch of the project. And in fact, though, the technical definition of branch is just a single commit, or rather a movable label that is pointing to a single commit. So if we look at this depiction of a Git repository as it has commits over time, first thing I'll point out is that the default branch name in Git is master. It can also be called main. My preference is to call it main. And in Git, you can also add your own branches. And typically, the branches will start pointing at the very last commit in the main branch. So here I'm going to create a branch called load data from the web. And I want to do this because, let's say I'm using NHANES data. Well, there's some small chance that NHANES will update its data sets, right? Like very small chance, but maybe they find an error. So they update their data sets that they host on the web. So if I've got some old NHANES files stored in my repo and I'm reading them in, I'm not going to get their update. But if my script will just read the NHANES data from the web the day that I run the script, then I will get their update. So I make this branch where I'm going to experiment with importing the NHANES data from their website instead of importing it from a static file. Now, when I start the branch, it's going to be pointing to the most recent commit in the main branch. But then I'm going to start working on the branch. And I'm going to make some commits. And every time I make a commit, the branch is going to point to that commit. And then here I've done a couple of commits, and now I'm pointing to the most recent commit in the branch. So all these blue lines or all these blue dots are showing you the work that I've been doing. And the main branch remains unchanged. And there's no limit to the number of branches you can create. If you want to, you can work on several things at once. Those tasks that you're working on won't overlap with each other. So while I'm working on this load data from the web feature, I can also do a pretty wild experiment that I don't think is going to work out. It's just something that I want to play around with, because all these branches can be very easily deleted, and you never have to worry about destroying your work because you've got this main branch that you're leaving relatively untouched. Branches are really useful to try things out. If you don't like it, you can throw them away easily, and you never have to worry about breaking your project. And once a project has kind of reached a certain level of maturity, the main branch becomes something that you don't work in very often. And instead, you start working a lot in branches because the main branch might become the live version of the code. So if your GitHub repository is being used to host a website, or if it's being used to host a paper, or if it's being used to host a book, you typically don't want to commit things to that live version of the project unless you really are certain they're going to work. And so once your branch is thoroughly tested, then you might want to bring it back in. So once you're happy with all the changes you've made in the branch, you need a mechanism to get those changes back into the main branch. And that mechanism is called a merge. So when I think this load data from the web feature is ready to be brought into the main branch, I'm going to do what's called a git merge. Excuse me. So when I do a git merge, the actual merge is going to combine all of the commits that have occurred in both of these two branches. And what I'm going to point out to you is that the main branch has been progressing while the load data from web branch has been progressing. And what may happen, this has definitely been a point of pain in learning Git. What may happen is, I may modify line 2 of the load data script in this commit, but this commit in the main branch may have also modified line 2 in that same script. So we have a change in that script in the main branch, and we also have a change in that script at the same place in the load data from web branch. And this creates a merge conflict. Merge conflicts are really, in my own personal experience, the hardest thing about using Git as a beginner, because they're very hard to navigate. Instead of kind of giving you a full rundown of how you deal with merge conflicts, I'm going to give you a visualization. And so this is how you deal with a Git merge in practice. You just kind of go through all the conflicts one by one and pick which branch you want to, choose for, the code version, and kind of hope for the best. Hope it doesn't break your project. I think Git merge conflicts should be avoided at all costs. And you can generally do that by communicating, telling your team members, hey, I'm going to work on this part of the project, and you should work on this part of the project, so that our work can be, done at the same time, but we're going to be sort of perpendicular in what we're doing. So my changes won't overlap with yours. So now we've covered a couple more jargon terms here. So a branch is a movable label that points to a single commit, and a merge is the combination of all the commits from 2 or more branches. And like I mentioned earlier, you can kind of see how you can't define merge without using the word commit and branch. So the jargon loop is very strong with Git. All right, so next thing about Git that is nice, it helps you back up your work. I think everyone here knows and already is backing up their work, but perhaps not everyone is backing up their work as regularly as we all know we should. Ideally, you want to back up your work somewhere that is not the same place as your computer. So one thing that I think people have done a lot recently is put their files on OneDrive, because it's a different place, which has a lot of advantages. Backing up to a different place is safer. If your office has a disaster and there's a fire, or if somebody breaks into the office and steals machinery, you could lose your files. So putting your files in a geographically distinct place protects you from that. It also allows you to access the files from different places, not just the office. So you can access them from home, you can access them from coffee shops, you can access them while you're on vacation. This is probably not a great thing when you think about it in the long term, but that's maybe a different topic for a different talk. And the last thing is you can share your files. So if you have somebody that you're working with, you can tell them, go to this OneDrive location, or here's the link to a box folder, and then they can engage with your files and you can work together. So in Git, the place where you can back up your work is called a remote. And now we're going to talk a little bit about the most popular remote, GitHub. GitHub is a website, and on the back end, it's running Git. And on the front end, it has this amazing, helpful user interface that works to fight against a lot of things that make Git so inaccessible. So to get some work from a repository, this is something that you do for the first time that you want to get the work from a repository. You will clone it. So a clone is when you have a remote, and notice how there's the remote label here, and you want to bring that remote down to your local computer. So you do a clone. And in my NHATES project, I had the help of this fellow right here, Li Gong Chen, who is a programmer at UAB, one of the sharpest programmers I've worked with. And he has helped me in a lot of my Git projects, helped me to do pull requests, push changes up to my remote, and work through merge conflicts together. So we've become very close friends over those shared traumatic experiences. And other people can clone it as well. So here we have Shakia Hardy. She's an epidemiologist at UAB, excellent writer, one of the best paper reviewers I've ever gotten to work with. And she also helped a lot with the NHANES project that I was sort of sharing earlier. So Li Gong and Shakia can clone the remote and have the local, have that work available to them in their local computer. And so once everybody has the repo on their computer, we can work on it in a parallel way. So Li Gong could make a commit on his computer where he modifies my code a little bit and he increases the decimal place accuracy of some coefficients that we use to compute CVD risk. And now he wants to get his changes sent back up to the online remote so that myself and Shakia can access them. So he's going to do what's called a push. He's going to push his changes up to the remote, like so. And now you'll notice that Shakia's repo is one commit behind the remote. So she's going to do, to get those changes, she's going to do what's called a pull. So she's going to pull those changes down to her local computer. And now, now collaboration has sort of happened because Li Gong has made a helpful change. He's pushed it up to the remote. And then Shakia has benefited from that change by pulling the most recent commit down from the remote. So I'm aware that I'm really throwing the jargon at you quickly now. So I'm going to review just a little bit. So when you clone a repo, you copy a repository from a remote location to your local computer. You only should clone once. Since once you have the repo on your local computer, you should be pulling the updates from that repo down, right? So you clone for the first time, and then when the remote location gets updates, you pull those updates in. Now, when you're ready to send some of your own work up to the remote location, you can send your local commits to that remote location using a push. So once you've gotten comfortable with that terminology, you just think, okay, I'm going to clone that repo, I'm going to work on it, I'm going to push my changes up to the repo, and if somebody else contributes to the repo, I'm going to pull their changes down. So this kind of leads us into the last nice thing about Git. It really helps you collaborate. And even though Git is enough to collaborate, GitHub actually makes that collaboration even smoother. So when you have a repository cloned, you can push and pull and work together. But of course, if everybody is pushing to the same place and nobody is kind of playing that guard to make sure that the pushes make sense, you could end up with a situation like this. You have all these talented chefs and they're all putting their work into the same pot, but nobody is coordinating, nobody is working out the hierarchy of like, how do I check to make sure that this new commit is not going to break the project, and you end up with too many cooks in the kitchen. So instead of cloning somebody else's repo, now we're going to move into a GitHub term. You can fork a repo. Forking is something that you can think of as a clone, but it's not the same thing as a clone. So when you fork a repo, you create a copy of it, but rather than put that copy on your local computer, you're actually putting the copy on your GitHub profile. So you have one remote, you fork it. Now there are two remotes. One remote that you don't have access to, that's somebody else's work that you've now forked, and one remote that you do have access to, one remote that you can commit changes to. So when you do this, you're in a great position to do what's called a pull request. That's where you've forked somebody else's repository. You've made changes to that fork. And now you want to say, hey, look, I saw your code, I downloaded it, I think it's great, and I've modified it. I think it's even better now. Would you like to take the modifications that I've made? And that's what initiating a pull request looks like. And then if the owner of that original remote likes your changes, they'll say, yes, please, I'd like your changes. And they pull those changes in. So a little diagram taken here from the Happy Git with Our book kind of shows you the fork and clone process. So up here, we've got the GitHub world. And then down here, we've got the local computer world. And on the left-hand side, we have somebody else's work. And on the right-hand side, we have our own work. So if we find this really cool GitHub repository that we want to contribute to, the first thing we do is fork the repository. Now we have a clone of that repository, but it's still on GitHub. Now we want to clone the repository to our own local computer where we can make changes. Pop over to the next slide now. So now we can make changes in our local repository and push those changes up to the repository that we have access to. So we haven't changed their work yet, but we're ready to initiate a pull request. So when we initiate that pull request, they're going to be notified that we've changed their code. They can come into our GitHub repository, see what the changes look like, make sure those changes aren't going to break their work. And if they like them, they can pull them in. And the only thing left for us to do is actually get those changes, so the owner may modify our changes, or the owner may ask us to change our changes slightly before they pull them in. And now we just need to pull those changes down to our local work to sort of complete this collaborative cycle. And we don't have that set up yet, but we can set it up by linking our local work to not just one remote location, but two. So generally, when you're working on something locally and you want to put it on GitHub, you'll just have one remote that you push up to. But if you're working collaboratively, you can set up more than one remote. So you can have an origin remote that you are the owner of, but then you can also have an upstream remote so that if somebody else, or if the owner of the repository makes a big update and you want to get those updates brought into your own local work, you can pull the updates down from their upstream remote. And so you have three components here. And when the process works as intended, you push up to your component, you initiate pull requests so that they can bring in your pull requests. And whenever they make changes to the remote, you pull the changes from the upstream remote down to your local work. And this dynamic is the way that Git is intended to work. And there are lots of reasons for that, safety reasons. It seems like there may be one too many levers in this process, but in fact, there are not. And I'm not the right computer science background person to explain why, but I hope you will trust me all the same. So let's kind of revisit our collaborative scenario here. We have Ligong and Shakia, and now instead of just having local work, they also have GitHub profiles. So we're looking at the remote GitHub profile of Ligong and the remote GitHub profile of Shakia right here. And so what they've done is they've pushed their changes up to their remotes. Shakia, in addition to Ligong making a change, Shakia has also made a change. She's just modified our code that creates our manuscript. And luckily, Ligong's changes don't overlap with Shakia's changes, so we don't have a merge conflict. But now what they're going to do is initiate that pull request. So I'm going to get a notification since I'm the manager of our main remote. I'm going to get the notification that Ligong has made a change and he's initiated a pull request, and so has Shakia. So I can go into these changes one by one, see how they look, and decide to pull them into our main branch. And now our repository looks like this. We've gotten both of their work integrated. We've incorporated the two commits, and we need to be careful now because we need to get those changes pulled back into Ligong and Shakia's local work. But we can't do what seems obvious. We can't just pull those changes down into Ligong's work because I kind of mentioned this before. Git will let you travel back through time, so you can look at your previous commits, but it won't let you change the past. And so there's no way that, since Ligong has made this commit right here, this blue dot, we can't suddenly slice that purple dot in there. And this is why it's very, very good practice. Whenever you initiate a pull request, you don't make changes in the main branch. You actually create a new branch and you name it after the feature that you're trying to put into the big, broad remote. Because when you initiate that new branch, you leave your local main branch untouched. So then you initiate that pull request, the changes go up to the repo online, and your main branch locally is just as it was when you created the change. So when the change is actually incorporated, you can easily pull the updated main branch into your not updated main branch and get everybody back on the same page. So you can have multiple people contributing to a remote online. Then when the remote is updated, everybody can pull those changes down into their main branch and not, destroy their projects. So once they've pulled those changes down into their local main branches, they can push the changes back up into their remote branches. And then we'll be at a very good place because we'll have successfully incorporated some productive updates into everybody's work. And there has been no merge conflict because we coordinated beforehand what people would be changing. And we also are at the exact same place that we began in regards to having the same work on all of our local and remote sites. All right, so I think at this point, it'd be fair to say that, for 50% of our audience, Git and GitHub were new things when they came in today. So if you have not heard of Git and GitHub before today, I have thrown about 10 jargon terms your way, and we've gone through all these diagrams, and it would be very valid for you to think this is a lot of information. So a great question would be, I can't just start doing this all of a sudden. What should I do to start? And I think, so my experience was that GitHub was a lot easier to engage with at first than Git was itself. On GitHub, you can peruse and you can look through other people's code, and you can just see some of these professionally maintained GitHub repositories and learn a lot. You just learn best practice by seeing how other people work. So what I would recommend you do is begin by creating a GitHub account. And this is the point in the presentation where I'm going to give everybody at least 5 minutes to, if you don't have a GitHub account, I highly encourage you create one, because that's going to allow you to participate in a couple of examples that we're going to walk through together. And I also can take a second where we go through some questions here. So if you don't have a GitHub account, feel free to ignore me. I'm just going to answer some questions as best as I can. Invest this time in going to the github.com website and go through the instructions to create a GitHub account. So I'm just going to, when you get to this screen right here, you'll get here after you do those like verify you're not a robot stuff. I've been using the free version for as long as I've been using GitHub. It's always been enough for me. So don't worry about getting additional benefits. If you're a student, you may be able to get some benefits for free, and I would certainly recommend that. So now, I'm just going to check the clock here. We're at 1:55, making good time. I'm going to open up chat and see if I can answer any questions. Come back up. Yeah, oh, I'm sorry. Looks like my dog got other people's dogs aggravated. That figures. So I have a question here from Miranda. It says, are all versions retained from previous commits? Are any versions overwritten? That's an excellent question. You will not have to worry about overwriting any of your previous commits. You can never change a previous commit. So it's a safety measure to make sure that you can't ever ruin or delete your previous work. Can you recover previous commits? Absolutely. You can always recover a previous commit using a checkout. And in fact, checkout is a Git command, but to tell you the truth, GitHub does checkouts a lot better than Git does. So here I'm looking at my Nhanes repository, and I'm going to show you a checkout as done through the GitHub user interface, right? You can do a checkout with the Git terminal commands, but God help you, that's tough stuff to do, to tell you the truth. And if you use GitHub and you're on a specific repository, you can actually just see this link right here where it says how many commits there are in the repository. Give that a click, and then you can see all of the commits for that project. You can see all of the commit header messages. You click on a specific one, and you can see what the changes were. And then once you've looked at the changes, you can look at the exact snapshot. So if you click Browse Files, you can see what the project looks like, the exact moment in time when you made that commit. So GitHub, when you're learning this stuff and you want to check out your old commits, I would really recommend GitHub. Sorry for my phone going off. Let me just silence that real fast. Thank you for that question.
Hey, Byron, I'm signing back in. My internet was cutting in and out too. So thanks for taking over the chat. So it looks like another question came in from Akash saying GitHub is a place to record your work progress, but you can't run your code from GitHub, right? That is, it is not a cloud like Rstudio cloud.
That is correct. You couldn't open up a session of Rstudio from GitHub and run your code. But GitHub does have a really cool feature called GitHub Pages. So GitHub Pages will actually host the output of your code. And that's what I've used to put our slides from today online. With GitHub Pages, you can push your code up to GitHub. And then yes, GitHub will be able to take the output of your code. So you have to push the output up there as well. GitHub won't run it for you, but you can push the output of your code up to GitHub, and then GitHub can send that output to a specific web page that corresponds to your specific GitHub repository. And that seems like a lot. So to simplify it, GitHub can take the output of your code and give it its own website, which is exactly what we did for our slides today. Thanks, Jamie.
Great. So Miranda has another question. For instance, if I change a data file by deleting a number of rows, can I recover that deleted data by checking out the previous commit?
Yeah, that's exactly what you can do. So if your commit message says delete a certain number of rows, you check out the commit just before that, and you'll see the data set that existed before you deleted those rows.
Great.
Great question.
I also just have a question about how you found your collaborators to be open-minded to learning Git and GitHub and working in this environment. Do you have any advice for kind of getting people started or advice for how to make that process go more smoothly?
You just have to sort of be this guy or girl. I spent a lot of time building trust. I'd say my collaborators were not interested in using Git or GitHub until we had worked together for a few years and they had built up a friendship with me, and they had respect for the way that I worked through code, and that made them feel interested enough to take on this new idea of learning how to use a new application.
Yeah, that makes sense. So here's another question from Miranda. Can you explain a bit more about the relationship between Git and GitHub? Are there other remotes than GitHub?
Yes, there are other remotes than GitHub. I think GitHub is the biggest remote source, but I think that there's also Bitbucket and some other, maybe GitLab, where you can push your local work and store it in a remote place. As far as the discrepancy between Git itself and GitHub, Git is the application that runs on your computer, so it does the file management work for you. GitHub is a website, and the website of GitHub runs Git on the back end. So GitHub will use Git to do some things, but when you use GitHub as a user, you're really just engaging with the website. And I'd say the strength of GitHub, apart from having a open source place to put all your work, the strength of GitHub is that it has really nice user interface tools, and it acts as this way to learn the functions and processes of Git, which is why I think it's the right place to start, and why I think you really, if you make an account today and start to just peruse, search, maybe even do some actions with GitHub, you will learn about Git in the process, and that'll help your transition if you want to start using Git in your work.
Yeah, that makes sense. Larry is curious, do GitHub and GitLab do the same thing?
I think GitLab has better privacy control. So I believe GitLab, you can store more sensitive data. But I want to say that as a very timid response, because I've never used GitLab and I've only heard about it, and I may be wrong. So Google would certainly answer that better than I would. Sorry.
No worries. Okay. Here's a question from Akash. Following up on the previous question asked, do we need to install Git or just sign up for GitHub?
Oh, that's a great question, Akash. So what I would like you to do is just sign up for GitHub now. You'll be able to work through our example just with GitHub. But when you do, if you start using Git in your work, you'll have to install Git. The thing that I would say is that when you install Git, before you install it, you should read through a little bit of the Happy Git with R textbook by Jenny Bryan, because it's going to guide you and make sure that your installation of Git is going to work well with your existing installation of Rstudio. Because one thing that Rstudio does really well is integrate Git so that you can use Git without already knowing how to use Git. So definitely check out the textbook before you install Git. And in fact, the textbook gives you step-by-step instructions to help install Git. So it's a great thing to read.
Yeah, I think that's great advice. Let's do one more question and then we can go on to the interactive portion. So there's a question about public versus private coding and everything on files on GitHub. So how can you protect your work or make it visible if you want it to be public facing?
Right. Yeah. When you create a repo on GitHub, you can choose whether it's a public one or a private one. And you can make a private repo and then you can invite people to it. So if you don't want the whole world to have access to your work, you can just make a private repo and then you can select people that you want to invite and they'll be allowed to view it, but nobody else will. Now for sensitive data, that's not really enough. If you need to store sensitive data, well, ideally don't store it on one of these remotes, but I think GitLab might be the solution for that problem. And I know I've been doing a lot of reading lately, and there are some enterprise solutions to storing really sensitive data in one of these remotes that can run Git for you. And I see one question in the chat about the textbook.
Yeah, I just sent the link.
Yes, thank you.
Yeah.
All right.
Okay, and then one other quick question, does Git work with SAS?
Yes, Git works with any kind of file, but the tricky thing is I'm not aware of, so I don't think that SAS has any tools that work as well as the Rstudio tools do as far as integrating Git through the SAS interface. So technically, yes, you could use Git to manage an evolution of a set of SAS files, but you'd have to be doing that through the terminal. Whereas I think with Rstudio, you can do a lot of Git commands through the Rstudio interface.
Great. Okay, let's continue on with our activity.
Perfect. So to get through this, I'm going to go half screen. And I'm going to give myself 2 tabs. So I've got my slides over here on the right. And I've got a little web browser over here on the left. And I'm going to try and walk through the steps, both through visual as, through the slides, but also just kind of do them myself. So first thing we want to do is go to my GitHub. And if you click this link, it should take you directly there. But I'm going to get to it from Google. And so now here we are at my GitHub. And what we do next is click on repositories. So you'll see the repositories tab is close to the top. And once we've clicked on repositories, you'll probably see seminar Git pretty close to the top. But if it's the second one in the list. But if you ever need to search for a repository, you should know that there's this nice feature where if you type in the name of the repository, it'll go through all the repositories in this user's list, and it'll find the ones that match what you're typing. So once you've found seminar-git, you can click on that. Now, here's the part where I will make a request. If you like this presentation, feel free to put a star on the repository itself. it'll help me as a GitHub user if, the stars reflect that people like what you're putting on GitHub. So if you don't like it, be sure to drop an issue in there and tell me that it's terrible. But if you do like it, you can star it, and that'll be very nice. So once you're inside of the Seminar Git repository, you'll be able to look at all the code. And what I'd like you to do is find the file called index.rmd. I see there's a message in chat. Thank you. I appreciate that. So click on index.rmd. Be careful. Don't click on index.html. This is just HTML code. And that is kind of what, that's what GitHub Pages is using to create our website. But we want to edit index.rmd because that's the actual code that creates the HTML file. So once you're in this window, you should see, I'm going to maximize my screen for a second. You should see a little pencil right here. If you click on the pencil, you'll do two things. You should be taken to a screen that looks something like this. So now you should be able to really edit this file. But I want to point out that GitHub has done a couple of things for you when you click on that pencil, things that we have already discussed doing. So when you click on the pencil, you should fork this entire repository. You're creating a copy of this repository on your GitHub profile. And that is essential because you're going to be creating a pull request. And as we've sort of discussed as well, GitHub is also creating a new branch for you just after you've done the fork. So you forked the repository, you created a new branch, and now you're going to create a commit. So what I would like you to do, once you've gotten to this editing screen, you're going to scroll down. This is a fair bit of scrolling now because there's a lot of code for this. You're going to scroll down until you find my exclamations and adjectives. So here is where I'd like you to provide your wonderful contributions and submit your pull request. You should find these on line 756. You're going to see that there's a list of adjectives, or I guess I should say a vector of adjectives, and a vector of exclamations. And later in the slides, these vectors are actually going to be used at random to create a slide for us, which we should see pretty soon. But what I'd like you to do is, just come in here and provide an extra adjective and an extra exclamation. I'll say cool. So you could, I'm not going to actually make this commit, but you make that change, and then you kind of bring your mouse outside of the code window so that you can scroll down below the code window. And then you're going to see this, this window right here where you can commit your changes. So now I'm going to say, add cool. Oops. I don't know if you really need to do an extended description for this kind of a change. But when you see this down here, if you see this, I don't know, you might not see this option if you're, like I have commit access here. So if you do see this option though, always create a new branch for this commit and then initiate a pull request. So let me see here, I see. Yep, good, we see proposed changes. And that's exactly what you should see. So go ahead and propose those changes. And then you should be brought to a screen that tells you that you are able to merge. You should not, so this should not cause any merge conflicts. And you basically just review what you've done before you click the button to finally create the pull request. And if you want to, you can leave a little comment in here. You don't necessarily have to though. And once you've created the pull request, you'll be taken to a screen. The screen will, you've officially created that pull request now. And this screen will serve as the place where I, or the owner of the repository, will communicate with you about the pull request. And so if I have changes that I want to make on top of your changes, this is where I will come and discuss those changes with you. let me go back to my slides. Okay. That really did not work the way I thought it would. There we go. All right, so if you didn't get to this screen, I've seen this happen in rare instances where you didn't get to the screen where you could make those changes. You could still actually go back to your profile page and make the changes in your own profile. And then you could initiate the pull request from there. And if anybody would like me to, at the end of the presentation, I'll demonstrate that. And we kind of got past this. Add your own adjectives. Yeah, I've moved past these slides. So I'm just gonna. So here we are, right? This is the slide. You've created your first pull request. Great work. After I've merged what I hope is a large number of pull requests, we will have many, many more adjectives and exclamations to randomly sample from. So I'm just going to check here. I see I have 9 pull requests. Excellent. So this is wonderful. I'm going to go into this one here. And so here we have add wow to exclamation. This was submitted by eMurphy100 in their new branch. Their branch is called patch-1. And I'm going to just review this. First time GitHub contributor. So I'm going to say that's awesome. And now I'm going to merge this pull request. Right, confirm. I probably should have checked it. Probably should have opened up the commit and checked it, but I was so excited that I got the pull request, I just merged it automatically. So now let me actually go back to my code. So now I'm going to see, I'm going to search for wow. Here it is. Here we have wow, and this is perfect syntax. They put the comma in, they put in the quotation marks. So this shouldn't cause any problem. And what I can do now is actually swap back to my Rstudio version of the project right here, and then flip over to my terminal. And this is extra, right? So you don't necessarily have to do terminal commands. But I'm going to see here that I've got a little change that I've made to the index.html. So let me just add that. That's not a good commit message, but I'm in a hurry here. So cool. So I had to commit those changes before I did a git pull to avoid having any conflicts, right? I don't want to have existing changes that haven't been taken care of before I pull those new changes in. So now, lo and behold, when I open up index.rnd, search for wow, I have pulled in the changes from my newest collaborator. So that's pretty cool. Now I can also recreate this file. So now I've recreated the slides, and I can go right back up to where I think the so here we are. So now we have new randomly generated exclamation and adjective. So pretty neat. And I will go through all these pull requests individually later so that everybody's work can be brought in. I really appreciate y'all taking part in the exercise. So now you're going to make your own repository. And that should be fairly straightforward because you can do this on GitHub. I have done this myself. I've actually created a second GitHub account called BC Jaeger Helper. And this is the profile for that. This is my dog, who has not really helped me out in the presentation as much as I hoped he would, but this is just a little thing that I created to do some experiments with. So what you should do is go to your own profile, click on repositories. You can see that right here. And then down on the right-hand side, you should see this button called New. So you'll click on that. Then you're going to be brought into a screen where you're going to provide some data for your repo. You're going to say what the repository's name is. You're going to give it a description and let's see here, give it a description. And then you're going to indicate whether you want it to be public or private. I recommend making it public. I mean, this obviously isn't going to contain any sensitive work. And it'll also allow me to potentially find your repository and make a pull request. So when you scroll down here, you should see some checkboxes that you can fill in. I would recommend you initialize with a README file. You don't really have to worry about the .gitignore and the license for now. You should read about them in Happy Git with R by Jenny Bryan, but for now, I think you should just initialize with a README file. So once you've clicked these boxes, you can finally find the big green button on the bottom that says Create Repository, and you should be good to go. So I'm just going to walk through that myself. I'm going to sign out of my GitHub profile. Then I'm going to sign in with my helper profile. And I'm going to do these steps really quickly. I'm going to go to my repositories. Oh, I guess I don't really have to do the steps because I already have this created. But I'll just kind of click new. I'm not going to go through with creating this, repository name, description, public, initialize with a README, and then you would click create repository. So hopefully that is a straightforward set of instructions. Once you've got a repository created, other people can engage with it. So we'll flip back over to the slides. We're now at roughly the end of the presentation. And so I wanted to give you a slide where you can review all the jargon. If you ever come back to these slides and you just think like, I really need to review the vocab before I get back into this, hopefully this slide will be useful for you. Now, in the last bit of time, I have about 5 minutes here. I want to show you a little bit of what you can do when Git is connected to Rstudio. And I want to show you this using a package called Use This. This is an R package that was developed by Jenny Bryan. It complements the tools that are already available in Rstudio to work with Git, but it is pretty snazzy. It is a very, very efficient tool. So I'm going to just do a demo for you. I'm going to create a project that uses Git and GitHub, and it's going to take me less than a minute. All right, so here we go. I'm working in Rstudio, and I'm going to call on the use this function create project. I'm going to create this project in a new directory called temp. Use this has created the project for me. So use this is really this cool little thing that you just tell it what you want to use. So now that I've got my new project, I want to use Git. All right, so this is going to work because Git is in a sensible place that Rstudio is aware of. So I have told Rstudio that I want to use Git, and it's asking me if it's okay to create a commit of my new project. I'm going to say yes, definitely. Now it's asking me if I should restart Rstudio so that I can activate the Git pane. I'm going to say yes. All right, so now I have the Git pane, and I have successfully created my first commit in my new project, and I want the world to know. So I'm going to use GitHub. So use this is creating a GitHub repository for me. It's pushing the changes up to that GitHub repository, and it's done. So we're up and running. We have a new repository on GitHub. We've created our initial commit, and we probably need to fill in some details, but we're in pretty good shape. So that didn't take too long. Next up, let's go back to the slides. We're going to create a project from GitHub by forking and cloning. So here, I think I'm going to try creating the project that my helper account has. Right, so here's my helper. My helper has a project called Git Seminar Helper, which is a helpful repository for someone who is making a Git seminar. So I'm going to assume that that's going to be helpful to me. So when I want to create a project from GitHub, I'm going to fork it, making a copy in my GitHub profile, then I'm going to clone it, bringing it down to my local workspace. Do I need to remember that? No, because the use this package has me covered. So I'm done with temp now. I'm going to close temp. I'm going to go back to the project where I'm creating my slides. I'm going to tell use this that I want to create something from GitHub. And to get that something, I just need to tell use this, all right, here's the location. Here's the username / the repo that I want to copy. So here we go. I am creating this project from GitHub. So I've now forked that project and then cloned it to my own my own computer. I've got all the files that were in this project to start with, and I am ready to make some additions. But before I do, I'm going to be a smart GitHub user, and I'm going to tell use this that I want to initiate a pull request. And remember, the main thing about pull requests is that we need to create a new branch where we're going to add the feature, because this branch can be easily merged into the main branch of the repository that we want to contribute to. And then we can pull those changes back into our main branch locally. So let's just call this add things. I'm going to create a branch called add things. So now I'm initiating this pull request, and I'm going to go ahead and add the things. Right? So I'm going to tell use this. Let's, oh, not add, use license, oops, use MIT license. So the MIT license is an open source license that tells people that if they're going to use your work, they should at least mention you, which is a very common license in the open source setting. And now I'm going to get really fancy, and I'm going to use a whole other package, tflow. I'm going to use tflow. So this is nice because this sets up my repository to work with a package called targets, which I will gladly give another 90-minute seminar on after I've recovered from preparing for this 90-minute seminar. So this is just a cool package that I think everybody should use, but I think I'm ready. So I'm gonna finish, let's see. I actually forgot what the command was, but I do know that use this gives me, oh, so here, use this actually tells me what I need to run when I'm finished with my pull request. So I'm gonna run PR push, use this, oops, PR push. All right, so use this is pushing those local changes up and initiating this pull request for me. Oh, I forgot to do something. There's nothing to compare here because I forgot to make a commit. So that was silly. Now let me go back to the terminal really quickly. I'm going to tell Git that I want to add everything. So I'm telling it, like, put all of my files into this next commit. I'm going to go into this git commit interface. Now I'm going to press I to start typing. This is going to add some files. And then I'm going to describe, these files are useful for just about any. So this is why I'm making the commit. So now I'm going to save this. So now I've actually done a commit. And so now when I initiate this pull request, it should actually be should actually have changes listed. Okay, so now I've initiated pull requests. You can see that the pull request has 1 commit in total, 7 files were changed, and there is 1 contributor. And if you look at the differences between the initial commit and the pull request that I am proposing, you'll see that all these things have been added. And you can see this indicated by the green text. If anything is removed, you'll see the change is indicated by red text. And I've gotten through, I did it, 5 minutes to spare. So that's as much. Well, I will also say, in case you're wondering, what is the sequence of functions that I just used to do all these 3 things? Here were the sequence of functions to use, create your package, create your project with Git and GitHub. And then if you want to fork and clone, you create from GitHub, initiate a pull request, finish the pull request, and then I believe That last thing was PR push. So I should probably go back and update this slide. Instead of say PR finish, maybe say PR push. And I almost forgot about this. We're at the very end. And now that we're at the very end, for those who are still here, if you would, open up these slides, go all the way to the end, and let me know how you feel about integrating Git and GitHub in your work after listening to this talk. Are you feeling like it's possible? You certainly don't have to feel confident. If anything, this should temper your confidence and make you feel like it is going to be slightly difficult. But let me know what you think. I'll type in my own response here. Hopeful.
Byron, while people are writing in, I just want to say a big thank you. This was an awesome presentation. Hopefully I'm not biasing your responses now, but I thought it was very helpful, great overview. And I think a lot of our members in the section will find it very helpful.
Yeah, I hope so too. And for the person who typed overwhelmed, I know that feeling. I think that's how I feel too sometimes, especially when it comes to merge conflicts. I appreciate everybody participating. I hope that you will get in touch with me if you have any questions. And certainly you can find me on GitHub. And I think you may also have my email address. So please feel free to reach out. I'm happy to answer any questions about any of this.
I think one question did come in. I think you can probably quickly answer. Akash is interested, does the use this package know the user's GitHub page? It didn't ask for login and password. So how does that interact?
This is a really wonderful feature of the use this package. You can connect your GitHub profile to use this in a secure way with Rstudio. So with Rstudio, and this is all detailed in Jenny Bryan's textbook, every single step for every single platform, for every single possible problem you can run into. So I highly recommend checking it there. But use this, connects your GitHub profile to your local Rstudio session, which allows you to do all these tasks very quickly. Because normally you would have to supply your username and password and things like that. You have to type it in for every commit, which would drive you crazy. And use this can bypass that by using a secure file that you manage that contains your sensitive information. And all that gets kind of automated for you. I really appreciate that question, Akash, because that's a kind of an important consideration. Let's see. So let me give you my email address. I'm just going to type it out in chat. I'd love to hear any thoughts or questions you have. And I'm happy to help with any confusion that Git may cause you. I feel like, it's a very good investment to go through this pain to get, the ability to collaborate with your fellow data scientists.
Awesome. Well, thanks again, Byron, and thanks to all of our attendees for participating today, and hopefully we'll see you next month.
Thank you.
All right. Bye.